Recap. So far we've covered a lot. First, we understood why traditional security models are no longer enough for cloud-first organizations. Then we learned what CASB is and why it was created. After that, we walked through the complete request lifecycle, from user authentication and device validation to policy enforcement. Now comes the section where many engineers get confused. Questions like, is CASB the same as SASE? Doesn't SWG already protect cloud traffic? If I have ZTNA, do I still need CASB? Does CASB replace a firewall? These are excellent questions. Let's answer each one step by step. The biggest misconception, CASB is SASE. One of the biggest mistakes I see during technical interviews and enterprise design discussions is this statement. CASB and SASE are the same thing. They are not the same. Let's understand why. Imagine you're building a modern airport. An airport contains many departments. There is security screening, immigration, baggage handling, air traffic control, passenger check-in, customs. Would you say the security checkpoint is the entire airport? Of course not. It's just one department. The airport is much larger. Exactly the same principle applies here. SASE is the complete architecture. CASB is only one security service inside that architecture. What is SASE? SASE stands for Secure Access Service Edge. Instead of purchasing separate security appliances for every location, SASE delivers networking and security as cloud services. Think of SASE as a cloud security platform that combines multiple technologies into one architecture. A typical SASE platform includes SD-WAN, Zero Trust Network Access, ZTNA, Secure Web Gateway, SWG, Cloud Access Security Broker, CASB, Firewall as a Service, FWaaS, Data Loss Prevention, DLP, Remote Browser Isolation, optional, Digital Experience Monitoring, optional. Notice something important. CASB is one building block, not the entire solution. Simple analogy. Let's use another analogy. Imagine you're building a modern hospital. The hospital contains emergency department, cardiology, radiology, pharmacy, ICU, laboratory. Would anyone say the laboratory is the hospital? No, the laboratory is one department. Likewise, CASB is one specialized security capability inside the larger SASE architecture. CASB versus firewall. This comparison becomes much easier if we first understand what a firewall actually does. A traditional firewall focuses primarily on network traffic. It makes decisions based on information such as source IP address, destination IP address, port number, protocol session state. For example, allow HTTPS traffic on TCP port 443. Block Telnet on TCP port 23. Allow DNS. Block FTP. These are network-level decisions. Now let's compare that with CASB. CASB operates much higher in the technology stack. Instead of asking, what port is being used? CASB asks, which SaaS application is this? Who is the user? What file is being uploaded? Is this customer data? Is the destination approved? Should this action be allowed? The firewall understands packets. CASB understands business activities. Real example. Suppose Alice uploads a confidential salary spreadsheet to Dropbox. The firewall sees HTTPS traffic, TCP 443, connection established. Everything appears normal. CASB sees user, Alice, department, HR, application, Dropbox, file, employee salary.xlsx, classification, confidential, destination, personal Dropbox account. CASB immediately blocks the upload. This is why firewalls and CASB complement each other rather than replace each other. CASB versus Secure Web Gateway, SWG. Now let's compare CASB with Secure Web Gateway. Many engineers think they perform the same function because both inspect internet traffic. However, their objectives are different. What does SWG do? SWG protects users while they browse the internet. It focuses on URL filtering, malicious website blocking, malware prevention, safe web browsing, acceptable use policies, internet access control. Imagine an employee trying to visit a phishing website. The SWG blocks the request before the page loads. Now let's look at CASB. CASB focuses on cloud applications. Instead of protecting web browsing, It protects interactions with SaaS platforms. For example, uploading files to Microsoft 365, sharing documents in Google Drive, exporting customer records from Salesforce, inviting external users into Slack. These are business actions inside cloud applications. That is CASB's area of responsibility. Easy way to remember. If the user is simply browsing the web, think SWG. If the user is working inside a cloud application, think CASB. One protects internet browsing. The other protects SaaS usage. CSB versus ZTNA. Now let's compare CSB with Zero Trust Network Access. This comparison often appears in CCIE, Palo Alto, and cloud security interviews. ZTNA answers one primary question. Should this user be allowed to access this application? It verifies identity, device posture, location, risk, context. After verification, ZTNA grants least privilege access. Now consider CSB. CSB assumes the user has already gained access. Its responsibility begins after access is granted. CSB asks, what is the user doing? What data is involved? Should this file be shared? Is this download allowed? Does this violate company policy? So here's a simple way to remember it. ZTNA controls access. CASB controls activity after access. Enterprise story. Let's imagine an employee named John. John works in finance. ZTNA verifies John's identity. MFA, company laptop. Device compliance. Location. ZTNA allows John to access Microsoft 365. Now John attempts to upload confidential merger documents to a personal cloud account. ZTNA has already completed its job. CSB now evaluates. What file? Which destination? Is this allowed? CSB blocks the upload. Together, ZTNA and CSB provide complete protection. CSB versus Firewall as a Service. Now let's compare CSB with Firewall as a Service. Firewall as a Service is essentially a cloud-delivered next-generation firewall. It provides Layer 3 security, Layer 4 security, application-aware firewalling, intrusion prevention, threat prevention, network segmentation, network policy enforcement. It protects network communications. CSB protects cloud application usage. Firewall as a Service decides whether network traffic should be allowed. CSB decides whether cloud activities should be allowed. Both are required. Complete SASE architecture. Now let's bring everything together. Imagine an employee working remotely. Employee. Identity provider. ZTNA. SWG. Firewall as a Service. CASB. Cloud applications. Let's understand what happens. Identity provider. Verifies who the user is. ZTNA. Determines whether the user should access the application. SWG. Protects web browsing and internet traffic. Firewall as a Service. Protects network traffic. CASB. Protects cloud application usage. Finally, the user reaches Microsoft 365, Salesforce, ServiceNow, Google Workspace, or any other SaaS platform. Notice something important. Each technology performs a different job. Together, they create a layered defense strategy. Real enterprise example. Let's walk through a complete enterprise scenario. A multinational healthcare organization has offices in India, United States, Germany, Singapore. More than 25,000 employees work remotely. Doctors use Microsoft 365. Researchers store medical reports in SharePoint. Finance teams access SAP. Developers use GitHub. Security requirements are extremely strict because patient data is highly sensitive. Here's how the SASE platform protects every user. An employee connects from home. The identity provider verifies credentials and enforces MFA. ZTNA confirms the employee is using a compliant corporate laptop and grants access only to authorized applications. The employee browses the internet. SWG blocks malicious websites and phishing attempts. Network traffic is inspected by Firewall as a Service to detect threats and enforce security policies. Finally, the employee uploads a spreadsheet containing patient records to Microsoft 365. CSB scans the document. It detects protected health information. The file is encrypted automatically. If the employee attempts to share the document with a personal email address, CASB blocks the action immediately and generates an alert for the Security Operations Center. This illustrates how each SASE component contributes to a secure, layered architecture. Common mistakes. Let's review some common misconceptions. Mistake 1. Thinking CASB replaces a firewall. Reality: CASB complements firewalls by adding SaaS-aware security. Mistake 2. Assuming SASE is a single product. Reality: SASE is an architecture composed of multiple networking and security services. Mistake 3. Believing SWG and CASB are identical. Reality: SWG protects internet browsing, while CASB secures cloud application usage. Mistake 4. Thinking ZTNA and CASB perform the same function. Reality: ZTNA controls application access. CASB controls what users do after they gain access. Mistake 5. Deploying CASB without integrating identity, endpoint security, and DLP. Reality: CASB is most effective when it works with identity providers, endpoint management, SIEM, and other security services. Enterprise troubleshooting methodology. One of the biggest mistakes new engineers make is troubleshooting based on assumptions. Experienced enterprise engineers follow a structured process. When a user reports an issue such as, "I can't upload files to Microsoft OneDrive," don't immediately assume CASB is the problem. Instead, verify the entire request path. A good troubleshooting sequence is user, identity, device, network, CASB, cloud application. Start at the top and work your way down. Troubleshooting scenario 1. Legitimate file upload is blocked. Imagine a finance user cannot upload an Excel file to Microsoft OneDrive. The user insists, "This is my normal work. Why is it blocked? How should you troubleshoot?" Step 1. Verify user identity. Check. Did the user authenticate successfully? Did MFA complete successfully? Has the account been locked? Has the user's department or role recently changed? Sometimes a role change causes different CASB policies to apply. Step 2. Verify device posture. Ask questions such as, is the device managed? Is disk encryption enabled? Is antivirus running? Is the endpoint compliant? Has the device recently fallen out of compliance? Many organizations only allow uploads from compliant corporate devices. Step 3. Review CASB activity logs. This is one of the most valuable troubleshooting steps. Review the CASB logs to determine which policy matched, which rule triggered, which cloud application was identified, which user performed the action, what enforcement decision was made. Never troubleshoot CASB without examining its logs. The logs often explain exactly why an action was allowed or denied. Step 4. Inspect the file. Was the file classified as confidential, internal only, highly restricted, public? Maybe the file contains credit card numbers, customer records, employee salaries, healthcare information, source code. If so, a data loss prevention (DLP) policy may have intentionally blocked the upload. Step 5. Review destination policies. Finally, verify where the file is being uploaded. Is the destination a corporate Microsoft 365 tenant, a personal OneDrive account, a personal Dropbox account, an unapproved SaaS application? Many organizations allow uploads only to sanctioned cloud services. Troubleshooting scenario 2. Shadow it detected. Now let's look at another common scenario. Your security dashboard suddenly reports that employees are actively using an unknown file-sharing application. What should you do? First, don't panic. Discovery alone doesn't mean it's malicious. Follow this process. Identify the application. Determine its risk score. Review how many users are accessing it. Determine what data is being transferred. Verify whether the application has already been approved by another department. Decide whether to allow, monitor, restrict, or block it. This process helps reduce shadow IT while avoiding unnecessary business disruption. Troubleshooting scenario 3. False positive DLP match. Another common issue is a false positive. Suppose an engineer uploads a test document containing sample credit card numbers used for software testing. The CASB identifies the content as sensitive financial information and blocks the upload. Technically, the CASB worked correctly. However, The business process requires that these test files be shared. How should this be handled? Rather than disabling DLP completely, create a more specific policy. For example, apply exceptions for the software engineering group. Restrict exceptions to approved repositories. Require manager approval for external sharing. Continue logging all activity. This approach balances security with business productivity. Best practices for CASB deployment. Let's now discuss the practices followed by successful enterprise deployments. 1. Integrate CASB with identity providers. Always integrate CASB with enterprise identity providers such as Microsoft Entra ID or Okta. This allows policies to consider user identity, department, role, group membership, MFA status, conditional access results. Identity is the foundation of zero trust. 2. Use data classification. Not every file should be treated the same. Classify information into categories such as public, internal, confidential, highly confidential. Once data is classified, CASB can apply different protection policies automatically. 3. Start in monitor mode. When introducing CASB into an existing environment, avoid blocking everything on day one. Instead, monitor user activity, analyze reports, identify false positives, fine-tune policies, gradually enable enforcement. This reduces user frustration and operational risk. 4. Combine inline and API-based protection. Inline CASB provides real-time inspection, immediate blocking, instant DLP. API-based CASB provides historical analysis, cloud storage scanning, compliance auditing, visibility into existing data. Using both models provides comprehensive coverage. 5. Regularly review shadow IT reports. Cloud usage changes constantly. Review application discovery reports regularly. You may discover new software as a service platforms, unauthorized collaboration tools, risky file sharing services, duplicate business applications. Regular reviews help maintain visibility and reduce security risks. 6. Integrate CASB with your security ecosystem. CASB should not operate in isolation. Integrate it with CM platforms, endpoint detection and response, EDR, security orchestration, automation, and response, SOAR, threat intelligence feeds, identity providers, endpoint management solutions. This enables faster detection, correlation, and automated incident response. Interview questions with brief answers. Let's review some questions frequently asked during interviews. Question 1. What does CASB stand for? Answer. Cloud Access Security Broker. It provides visibility, compliance, data protection, and threat detection for cloud applications. Question 2. Why do organizations need CASB? Answer. Because traditional firewalls cannot fully inspect user activities and sensitive data within software as a service applications. CASB provides visibility and policy enforcement for cloud services. Question 3. What are the 4 core functions of CASB? Answer. Visibility, compliance, data security, threat protection. Question 4. What is shadow IT? Answer. The use of cloud applications or technology services without approval from the organization's IT department. Question 5. What is the difference between CASB and SWG? Answer. SWG secures internet browsing by filtering websites and blocking malicious content. CASB secures cloud application usage by controlling user actions and protecting sensitive data. Question 6. What is the difference between CASB and ZTNA? Answer. ZTNA determines whether a user should access an application. CASB governs what the user is allowed to do after access is granted. Question 7. Can CASB replace a firewall? Answer. No. CASB complements firewalls by providing cloud application visibility and data protection, while firewalls focus on network traffic control. Question 8. What are the 2 main CASB deployment models? Answer. Inline, proxy-based, API-based. Many enterprises use both together. Question 9. Is CASB part of SASE? Answer. Yes. CASB is one of the core security services commonly delivered within a SASE architecture, alongside SD-WAN, ZTNA, SWG, and Firewall as a Service. Question 10. Which industries benefit most from CASB? Answer. Any organization using cloud applications can benefit, but it is especially valuable in industries handling sensitive data, such as finance, healthcare, government, retail, education, and technology. Final summary. Let's conclude by bringing everything together. Cloud computing has fundamentally changed how organizations operate. Employees now work from anywhere. Applications are hosted in software as a service platforms. Sensitive business data moves continuously between users, devices, and cloud services. Traditional security tools alone cannot provide the visibility and control required for this new environment. That's where CASB becomes essential. A CASB helps organizations discover cloud applications, including shadow IT, monitor user activities within software as a service platforms, protect sensitive data using DLP and policy enforcement, detect threats such as compromised accounts and risky behavior, support compliance with industry regulations, integrate with identity providers, endpoint management, and the broader SASE ecosystem. The key takeaway from this entire video is simple. SASE is the complete architecture. CASB is one of the specialized security services within that architecture. Remember this relationship, and you'll avoid one of the most common misconceptions in modern cloud security. If this video helped you understand the difference between CASB and SASE, please give it a thumbs up and share it with your colleagues. If there is a specific topic you'd like to see next, let me know in the comments. Thank you for watching. Thank you for learning with SASE Cloud Networking, and I'll see you in the next Enterprise Networking Deep Dive.